Building industry contribute to global warming and climate change in many ways, starting from production of material at the factory, transportation to the construction site. The process use energy called embodied energy, or energy is used during the construction. Once the construction is finished, the building uses less energy to operate building, lighting, air conditioning, refrigerating, and so on. Once the building gets old, it is torn down to build a new one, causing lots of solid waste. According to the United Nations Environmental Program or UNEP, building construction and operation worldwide account for 36% of energy and 39% of carbon emissions. Building material account for half of the solid waste generated every year worldwide. To construct buildings, we must consider how to use less material, how not to waste it, try to reuse or recycle, and how it will perform during operation. The life cycle assessment of a building involves evaluation of the environmental impacts throughout its life, normally 40 to 50 years. During the design, we need to know ahead of time about how much energy our building will use, how much wastewater it will generate, or how many kilograms of carbon it will give off. Beyond that, how we will dispose our aged building, any possibility to reuse it at the end of life. There are data available for estimation of embodied carbon of building materials. Using natural material will reduce carbon footprint of your buildings. Here are some examples of buildings in developing countries that use compressed earth block to build houses. Thermal energy can be saved compared with those used in typical bricks. Some buildings are looking for innovative ideas about how to reduce building weight by replacing concrete with plastic balls to save material and cost for the building structure. Some countries are trying to use low carbon material such as timbers to replace high carbon material such as concrete and steel. However, do they perform better during operation? Let us consider 3 building types in Thailand as an example. The emission per occupant from single house is the highest. However, the emission per unit area is the highest in office buildings, as it is normally used in the daytime when the outside air is hot and the building needs air conditioning. A house in a hot humid region can emit 57% of its total lifetime carbon dioxide during operation, mostly due to the use of air conditioner. This number can be offset by the use of renewable energy. Also, the need for air conditioning can be minimized by following the integrated approach that was presented in video 1.7. However, the rest 43% are caused by production and transportation of building material that cannot be offset. Net zero energy use is possible through the use of solar energy and passive design. The embodied energy can be higher by 20% because of the energy used to produce solar PV system, but operational energy can be reduced by 66%. Using passive design, the energy use of air conditioner can be reduced by 50% without increasing the embodied energy. Moreover, lowering energy use will help homeowners to cut investment costs and renewable energy. If a house uses less energy throughout its life, 50 years, the greenhouse gas emission that cause global warming and climate change can be controlled. If the building is designed poorly for the climate, then its lifetime operating energy would be much higher over its life compared to the embodied energy. If the building is designed with bioclimatic principle, then its lifetime operating energy would be lower, but still higher than the embodied energy. If the building is designed with bioclimatic principle and energy efficient appliances, then its lifetime energy would be much lower, comparable or less than the embodied energy. If, on the other hand, the building life is reduced from 50 to 30 years, the embodied energy will be more dominant compared to the lifetime operating energy. So, apart from considering the embodied and operating energy issue, it is important to also design buildings that last.